On this is 37. We're asked to sketch the graph of the logarithmic function. And again, we can do this by transformations. So the basic function, if we're graphing y equals log base 5 of x, you can plot a couple of points knowing that this is just a basic logarithmic function. We know that the point 1, 0 is on the graph. And if you want to put a couple more points on that graph, we could plug in, putting that in exponential form, 5 to the y power equals x. I could plug in a 1, so 5 to the first power would be 5, and 5 to the second power would be 25. So those 2 points would be 5, 1, and 25, 2. I plotted those points here. Here's 5, 1, and 25, 2. So there's your basic logarithmic function. The transformations are going to move that graph to the left 4 because of the plus 4, adding 4 to just the x piece, and then down 2. So I'm going to take that point 1, 0 and move it to the left 4 and down 2. So your point ends up being at -3, -2. Um, And then if we want to go ahead, we could move any of those other points as well to the left 4 down 2, or another way to find at least where that x-intercept would be to find the x-intercept by letting y equal 0. So when we let y equal 0, I get 0 equals log base 5 of x plus 4 minus 2. Move the 2 over. And then when I put this logarithmic function into exponential form, you would get 5 squared equals x plus 4. So that's the same thing as 25 equals x plus 4, or x equals 21. So your x-intercept ends up at the point 21, 0, which is exactly where it would fall if you were to move this point 25, 2 to the left 4 and down 2. You want to make sure and probably draw that vertical asymptote in. I didn't mention that. The vertical asymptote of log base 5 of x is x equals 0. So if that graph is being moved to the left 4, so would the vertical asymptote. So the vertical asymptote would be drawn in at x equals -4.